Now starting with this unit number 3. Unit number 3 is about the process management. What are the points to be covered in this unit number 3? The first point is what the process. What is the concept of process? And what are the different steps of the process? And what is a process control block? So you will be learning all these things related to the process. Then next we will be learning about the process scheduling, right? That is, if more than one number of the processes are running, how to manage all those processes and how to schedule all those processes comes to the process scheduling. So that point will be same. Then next point would be inter-process communication, right? How processes on a same system or on a different system communicate with each other. There are different models for it, and we are going to see those models. Next, what is the concept of a thread? And again, there are models for the threads also. So, what are those threads models? And lastly, what are the commands to be executed into the Linux shell and the commands which are related to the process commands, right? Now moving to the next concept of the process, right? Moving to the next concept of the process. See, actually, lot many times we have seen the process concept, right, in previous of the sessions, right? So again, to speak about what is a process, we have seen a process is what program in execution, right? A process is a program in execution. If there is my program, say my C program, my Java program, if it is stored onto the disk, it is a program. And the moment I take that program for the execution, for running, it becomes a process, right? So we are now very well familiar with this process concept. Now what next is what process execution must progress in a sequential fashion, right? A process execution must progress in a sequential fashion. That is, whatever is processed, that process would be, of course, executed in a sequential fashion in the sense, if I take a particular program, it will be executed line by line only. It will not jump here and there. It will jump when there would be a function in a picture, right? Otherwise, it will proceed in a sequence. And no parallel executions of the instructions of a single process. So, जो एक जो process है single process है, that process will not execute the instructions in a parallel. So at a time वो sequence में ही काम करेगा, ऐसे parallel में काम नहीं करेगा, right? So if it is a turn of parallel, then there would be the concept of the thread. So right now we are speaking about a single process that will execute in a sequence, not in a parallel, right? Now next, seeing into how this process is stored into the memory when we call upon it for the execution. Now for us, we are more and more about concern of program code only, right? So we think that this is my program, so I am concerned of code only. But when that program has become a process, that when it has become a process and it has been called upon into the main memory, it needs to maintain many of the things along with the code. The code is not the only thing. So this is what the diagram to the right side explains you, that how a process is stored into the memory, right? How a process starting from the zeroth address, that is starting from the lesser address into the upward direction to the maximum whatsoever is required for that process, right? And how this is the way it is stored into the memory. Now let's see the first portion. The first part is what the text part. So the first part, text part, what it says, the program code is called as the text section. That is, whatever the code I have written for that particular program, right, that code will be stored into this section. This the code of the program would be stored into this text section. Now the next section is what the stack section, right? So stack is what? Stack contains the temporary data. Stack contains your temporary data. During the execution of your program generates many of the temporary data and let's say specifically the local variables. If my program has some variable, say integer a, at the start of the program, I may say integer a is equal to 5. During runtime somewhere, a might have been assigned a value as a is equal to a plus again 10, that is a becomes 15. So again the value of the a would go on changing. So this is what the temporary data being generated through the program, through this particular process during its execution, right? There could be the function parameters, then the return addresses, and such many things. So such all temporary data is being stored into the stack section. Such all data is being stored into the stack section. Now what next is what the data section. Data section contains the global variables. Now global variables, you must be aware that the variables which are declared outside of your main program and global variables value do not change throughout the program and it could be shared, right? So these are the global variables. So data section is the section which will store the global values, variable values. Next comes is the heap section. Next comes is the heap section. It is what? It is a memory dynamically allocated during the runtime. So what heap says, that is dynamical allocated memory. As dynamical, it means it is allocated during runtime, and of course it is demanded during runtime, right? It is demanded during runtime, and hence these arrows are shown because there is no fixed size of this memory. So based on the requirement during the program, the dynamic memory requirements should be generated and that would be allocated and that would be stored over here, right? We'll speak about the program counter and registers later. Right now it's not part of this menu. So all this is what your process needs these many apart from this text. Apart from this text, we are familiar with the text only because that is the code of the program only. But the code of the program is not the whole thing, right? Code of the program is not the whole thing. So apart from this code, these are the few of the things that process needs to be stored along with it, so as it will need it somehow for the next processing, right? So this is what all about the process concept and how process have been stored into the memory. Again ahead is process concept itself, that is continued. Again, what is said that the operating system executes a variety of the programs that runs as a processes, right? So whatever different programs are being executed by the operating system, those programs runs as the processes. Those programs runs as the processes. Now we have seen even this particular statement also, program is a passive entity stored on a disk, right? Whereas process is an active entity, right? When program is stored into the disk, onto the disk, it is a passive. Passive stands for it do not do anything interactive. It do not do anything. Though it's an executable file, but it do not do anything. Whereas process, it becomes an active entity, right? That it is doing something, it is being executing, it is generating some local data, temporary data, right? So it is an active entity. Next is what program becomes a process when an executable file is loaded into the memory. That's what we are speaking lot many times about the same thing. Program becomes a process when executable file is loaded into the memory. The last point is what? Execution of the program. Now, how do we execute the program? That execution of the program starts via, right? Either we click through this GUI, that is through this GUI, either we click the mouse or else we can typing something to the command line entry, right? Etc. These are majorly, there are the two ways for execution of the program. That is either we double click on that particular executable file and we opens up it, we starts this execution, or from the command line we can type in the things, right? That is what the process concept. To the example of this process into the memory. So what this says, memory layout of a C program. try to compare this whole program into the diagram which we have seen onto the previous screen, with the diagram which we have seen into the previous screen, that how the different data required for that process. As we say that when a program is called upon into the memory, it becomes a process, and we know that it requires a memory. It requires some space into the memory. And now it is clear to us that process simply does not mean the program code. Process simply does not mean a program code. It carries few of the other things along with it for its execution, because it needs for its some tools, of course, it needs something extra for its execution. So now, as we said that what is the text? So text is a lower portion of this particular process into the memory. So text would be storing whole code into the text section. Then what these two says, uninitialized data and initialized data. That is what your data section, into which we'll be storing your global values, right? Going back to our diagram, that is C. This is our section is the data section, and what data section stores? Data section stores the global values, right? So over here, data section, these two comprises of the data section. One is an initialized part and other is the initialized part. So this is what a global. Now these two variables, integer x and y, which have been defined outside of the integer main, right? It has been defined outside of the main, and hence they are global, and hence they are stored into the data section. Now what heap section stores? Now see, heap section stores this value, integer malloc. Now you are already aware and must be that calloc, malloc, these are the functions which creates the dynamic memory, right? Which gives calls to the dynamic memory. So here it will here it will create a dynamic memory for the integer, right? It will create a dynamic memory for the integer and of course for the 5 integers. And of course now what it says, it is a portion which needs dynamic memory, right? So whatever the dynamic memory required will be created over here as per the requirement. अभी यहाँ पे integer और 5 integers के लिए it will create a memory for the 5 integers. Next is what stack. What stack shows? Stack stores the local variables. Now this int values and I, as they are inside the main program, they are your local variables, and hence they are stored into the stack section, right? And the outpost is what the argument C and argument B. These are the arguments to be passed to the main method of your program, the main function of our program, right? Where from the execution of the program, the execution of the process starts. These are normally the command line arguments and to be passed for the main program, right? So this is what how your process is represented into the memory. So these all things goes into the different sections for storing and for further requirement. Let's start with the different processes of a particular different steps of a process. Now once your program has become a process, once your program has become a process, during its execution, that is throughout its life cycle, this process goes to the different states. This process goes to the different states. Are those states are represented into this diagram. Now different states, for example, if I give you example of a cooking, the food during this whole cooking process goes to the different states, right? For the first state would be hitting a pot, then second state would be putting something into the vegetables, let's say. The state of the vegetable would be initially cold, then it would be warm, then it would be uncooked, then at the sometime during the sometime it will be boiling, and at the end it will be a cooked food, right? The same food goes through different steps during its whole cooking process, right? Same thing, these processes goes through the different steps throughout its life cycle. Now the first state, when a program becomes a process, the first state is the new state. So what the new state says, the new is the process is being created. Process is simply created right now. Now next step is what? Now in this diagram, please look into the directions of the arrow. These are very important, right? So from the new state, ready state has been created. So from the new state, process enters into the ready state. Now what ready state says, that ready state, the process is waiting to be assigned to a processor. The process is waiting to be assigned to a processor. What does it mean now? That is, process has entered into the new state, right? This is, say, let's you have some racing competition, running competition. You all are the participants, right? Once you enter onto the ground, you all are the participants. You are into the new state. That is, you have entered onto the ground. But are you ready to run immediately? No, you are waiting for something, waiting for some result, and even you are in not a state to get set go, right? So the next state, the first state you are on a ground, that is you are in a new state. Now the second state, you all will stand in some parallel line. You will be taking some pose, and now you will be waiting for 1, 2, 3, get set go, start, right? The position when you are carefully listening to, when you are carefully listening to, is it get set go, that is you are in a ready state to start your race, right? Same thing, your process, what ready says, that your process is now ready to execute. Now when your process will get ready to execute, in our example case, when you all will stand on a same line, when you will take some position, when you all will be alerted to listen to some signal, that is you are in ready state. Now, what about this process? We say the process is in a ready state. That is when process has acquired all the resources it needs for its execution. उसे execute करने के लिए क्या क्या resources चाहिए? तो process will acquire all those resources. जैसे कि उसे I/O devices चाहिए, उसे कुछ कभी memory चाहिए, and apart from that, कि सारे registers ready है क्या, उसका PCB ready हो गया क्या? So this is what process acquired all the resources required for its execution, except, underline the word, bold the word, capitalize the word, except CPU. CPU is also one of the resource required for the execution of this process. But when we say process is ready, उसके पास सारे resources है, but it simply do not have the CPU. That is what it is said, that it is waiting to be assigned to processor. Now it is waiting कि मुझे सिर्फ CPU मिल जाए, अभी मैं काम कर सकता हूँ. When the process is in a new state, it cannot work immediately because it might lack some of the resources. Why it might lack? क्योंकि जैसे कि ये एक प्रोसेस है, ऐसे बहुत सारे प्रोसेसेस सिस्टम में रन कर रहे हैं, उन लोगों ने सारे रिसोर्सेस लेके रखे हैं. तो when from new to ready state, ये से फ्री हो जाएंगे, वो सारे रिसोर्सेस ये प्रोसेस ले लेगा, and then it will enter into the ready state. So ultimately, ready state says that a process has acquired all the resources except CPU, whichever are required for its execution, right? Now next, from the ready state, it goes into the running state. अभी क्या बाकी था? रिसोर्स को रन होने के लिए सिर्फ CPU बाकी था. आपके केस में सिर्फ एक सिग्नल बाकी था, go, right? तो यहाँ पे सिर्फ CPU बाकी था. So what running says, that when a process has got a CPU for its execution, then at that time CPU process will enter from ready running state. Let's see what it says over here. Running is what instructions are being executed. Means what? When your process is into the running state, what it is doing? It is executing, right? Into the ready state, it is not executing, whereas in a running state, it is executing, right? So instructions are being executed. And what we can say, that when process has acquired a CPU, it enters into the running state, right? After that, when what about the waiting state? Waiting is the process is waiting for some event to occur, right? Now going back to our running state, say from running state, process will enter into the waiting state. It is of course if required, not always, right? if during its execution process needs some IO event. IO event stands for input output event. For example, in our program, if my program says enter some first number, right? It has displayed a message onto the screen, right? Now it is waiting for the number to be entered from the user. So it is expecting, it is waiting for the IO event. Which event? It is waiting for the number typing from the keyboard. जब तक मैं कीबोर्ड से नंबर टाइप नहीं करती प्रोग्राम आगे नहीं बढ़ेगा. तो प्रोग्राम कहाँ पे गया? अभी वेटिंग स्टेट में गया क्योंकि उसे अभी सीपीयू नहीं चाहिए. Right now do not need a CPU because it is waiting for the input device. Now once this event, whatever it was waiting for, is completed, once this event, whatever it was waiting for, in our case entering a number, hitting a number from the keyboard, right? Once it is over, your process will enter back into the ready state from the waiting state. प्लीज माइंड, ये वेटिंग स्टेट्स में वापस रनिंग में जाएगा नहीं, क्योंकि जब ये प्रोसेस रनिंग से वेटिंग में आ गया ना, तो दैट टाइम उसका सीपीयू फ्री हो गया है, राइट? दैट टाइम इट्स सीपीयू हैज बीन फ्रीड एंड हैज बीन गिवन टू समवन एल्स. तो जो भी अदर प्रोसेसेस वेटिंग में थे ना, उनको दे दिया वो कि अभी भाई तू वेट कर रहा है ना, तब तक सीपीयू तो खाली नहीं बैठेगा, क्योंकि मेन एम ऑफ द ओएस इज व्हाट? टू ऑप्टिमाइज the performance of the CPU. That is, keep the CPU busy all the time. CPU बहुत expensive resource है, तो उसे all time busy रखा जाएगा, right? So जब ये process waiting में आ गया, by that time this CPU has been given to some other process, right? So इसलिए waiting से पीछे वापस running में नहीं जा सकता, क्योंकि CPU कोई तो भी use कर रहा है, फिर वो वापस ready state में जाएगा कि वापस की what your process will say, भाई अब मैं वापस, मुझे CPU चाहिए, मैं वेट कर रहा था आईओ के लिए, अब मैं रेडी हो गया हूँ, मुझे आईओ मिल गए हैं, आई एम रेडी टू गेट द सीपीयू, राइट? इन दैट केस अगेन वी एंटर इनटू द सीपीयू केस एज एंड व्हेन नीडेड. So next is what? In few of the cases your process may enter back into the ready state directly without waiting. What is that situation? That is what? Whenever some interrupt has occurred during the execution of the process. If some such interrupt has occurred, वो directly running is a ready state. And the last is what? Is terminated state. Terminated has finished its execution, right? Once the whole execution of the process has been finished, it will enter into the terminated mode, right? It will enter into the terminated mode, that my process execution has been done. In that case, it might have released the resources which it has required except the memory. जो मेमोरी में वो प्रोसेस मेमोरी में है, इसलिए वो मेमोरी अभी छोड़ेगा नहीं. बट अपार्ट फ्रॉम मेमोरी उसने जो भी कुछ रिसोर्सेस एक्वायर किए थे, उसके रिसोर्सेस वो रिलीज कर देगा, राइट? सो दिस होल इज व्हाट? द डिफरेंट स्टेट्स ऑफ द प्रोसेस थ्रू व्हिच प्रोसेस passes throughout its life cycle.